4, 5, and 6 are identifying numbers as rational or irrational. A rational number technically is any number that you can write as a ratio of two numbers. Well, a ratio of two numbers looks like this. To me, I call that a fraction. So, a rational number is anything you can write in the form of a fraction. There are a whole ton of things that you could change into fractions besides fractions. We, of course, have fractions and mixed numbers, right? Because if I had 1 2/3, I could change it into an improper fraction if I wanted to. I have whole numbers. How do I change my whole number into a fraction? I put it over 1, right? If I have 3, I write it as 3 over 1. It's now a fraction. I have square roots of something that are perfect squares. What's a number that's a perfect square? 9. If I did the square root of 9, I would get the whole number 3, and then I could change it into a rational number by putting it as 3 over 1, right? I have terminating decimals. What's a terminating decimal? Terminating. It stops, right? When you terminate something, it stops. So a terminating decimal, something like 0.25, if I read that correctly, that is 25 hundredths, right? Tenths, hundredths. So 25 hundredths, which I could reduce down to 1/4, but I can write it as a fraction. Repeating decimals. Repeating decimals. 0.33333333 is probably one that's really common. Although it's a lot harder to change it into a fraction, just know that it can be done. Does anybody know what fraction that's equal to? 1/3. If you take 1 divided by 3 on your calculator, you're going to get 0.3333333333. So, anytime you have that repeating decimal with that bar over the top, just know it could be changed into a fraction. It just takes a little bit more work, and we're not worried about how to do it. So, there may be some other things, but these are the types of things that they're going to give you on ALEKS that are going to be in the rational category. Irrational. Technically are non-terminating, non-repeating decimals. Non-terminating, non-repeating decimals. That symbol there, does anybody know what that symbol is? Pi. Do you know how you get pi? It's the circumference of the circle divided by the diameter of the circle. You'll always get the same number. Pi, if you use your calculator, who has their calculator handy, is in yellow above that EXP key way on the bottom. So if you hit Shift and EXP, the pi symbol shows up on your calculator, right? Probably not yours, but on your cell phone. And if you hit equals, what shows up on your calculator screen?
3.14159.
I got the 3.14159.
2654.
And it keeps going and going and going and going and going and going and going forever. Some crazy person had it memorized to like some thousand places. But it's a decimal that doesn't end and doesn't repeat. The only reason the calculator ends is because it can't show that many numbers anymore. It just cuts it off, right? So pi is irrational. Anytime you see pi on one of your problems, you're always going to end up with an irrational number, because if I take something times pi, and pi is irrational, I'm still going to get an irrational value. The other way you guys are going to get irrational values is when you work with radicals. What's a radical? Square root, cube root, fourth root, those kind of things. They're going to do square roots. So if I do the square root of something that is not perfect, give me a number that's not perfect.
5,
7, something like that. Put the square root of 7 into your calculator. What happens when you do the square root of 7? Square root button, by the way, is right next to the fraction button. It's the third one down in the second column there.
2.6457311.
2.6575 something 311. But again, you get that decimal that just keeps going and going and going and doesn't repeat and doesn't terminate. So I suggest when you're doing these, pick out your irrational values first. We already know this one's irrational. It had pi. Then we look and we say, okay, I've got 2 of them that has square roots. Oh, this one happens to have the square root of 7. We already figured out that was irrational. This one also has a square root, but what is the square root of 49?
7.
7. That's a nice whole number. That's going to be in my rational column then. Now the other 2 don't have anything to do with our irrational numbers, but if we look, this one is a repeating decimal. Repeating decimals are rational. This one is a fraction, and that's really what a rational number is. If you say, or if you read the directions of something, and it says adding rational numbers, you know you're going to be adding fractions. All right. Clear as mud. We'll try the next 2. So, number 5. Look at your list, pick out the 2, because there's always on Alex, they're not very creative, just going to be 2 that are irrational. Which 2 are irrational on number 5? The 19 pi is irrational, and the square root of 3 is irrational. That means the rest should be in our rational column. Here we have a fraction, which is what a rational number is. Here we have a repeating decimal, and here we have a square root that's a perfect square, and so all of those are rational. Go ahead and do number 6 while I move the board. So, 24.89 repeating is rational. Negative 3 times the square root of 2 is irrational. Negative 3/6, rational. Negative square root of 4, rational. And pi, irrational. Exactly.